So in this question, we've been asked to prove that the R fan of x is equal to this, where x is between k and negative k, and we have to state the value of a constant k. So the first thing we need to do is if we say that y is equal to the R fan of x, and then we take the fan of both sides, then the fan of y will equal to x, because these two will cancel. And we know that the fan of y is equal to the sine of y divided by the cos of y. And now we need to write each of these in exponential form. We know the sine of y is e to the y minus e to the negative y over 2, and the cos of y is e to the y plus e to the negative y over 2. So now we need to substitute each of these into here. We can cancel out this division of 2 by multiplying both by 2, so we get this. And then we can cancel out this e to the negative y by multiplying both the numerator and denominator by e to the y. Because then what will happen, when you multiply this term by this term, we add the powers, so we'll get e to the 0, which is 1. And when you multiply e to the y by e to the y, we get e to the 2y. And we know that the fan of y is equal to x. So we can say then that x is equal to e to the 2y minus 1 over e to the 2y plus 1. And now to find the inverse of this, we'll move the denominator to the left-hand side, and then we'll expand out the brackets. Now, because we want to make y the subject, we need to move this term to the right-hand side and the negative 1 to the left-hand side. And then we can factor out e to the 2y on this side, and then we'll divide both sides by 1 minus x. So now we'll take the natural log of both sides. These will cancel, so we get 2y is equal to the natural log of x plus 1 over 1 minus x, and then we'll divide both sides by 2. And then we're told in the question that x ranges from positive k to negative k. Well, we know the lowest that this could be is positive 1, so x plus 1 must be greater than 0, which means x must be greater than negative 1, and 1 minus x must be greater than 0, so x must be less than positive 1. So we know that k must be equal to positive 1. Okay? Let's move on to part B. Hence or otherwise solve this equation. Well, we've just proven that this is true. So it makes sense then to leave a natural log term on this side and move this fan term to the other side, because then this will give us an R fan, similar to what we have here. So if we take the R fan of both sides, will give us the R fan of 2x equals the natural log of root 2 minus 3x. Then we can use the power rule of logs to move this root to a power of a half, which we can then move in front here. So now we've got an equation looking more like what we've just proven. If we replace this x with the 2x, then all we need to do is to substitute the 2x into the right-hand side. So now we get the R fan of 2x is equal to 1/2 the natural log of 1 plus 2x over 1 minus 2x. And now this will be equal to this right-hand side. So now we can write this into here. Then we can cancel out the halves. We can cancel out the natural logs. So we're left with 1 plus 2x over 1 minus x will equal 2 minus 3x. We'll move this over to the right-hand side, then expand out the brackets, and then we can tidy up this quadratic and make it equal 0. We can solve this on our calculators, and we get x must equal 9 plus or minus root of 57 over 12. But remember that x has to be between 1 and negative 1. So therefore, x is equal to 9 minus root 57 over 12. Okay? Well, thank you for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the lesson on solving hyperbolic equations from my website, mrmathematics.com. I'll leave a link in the description below.